everyone, let's just take next type of the numerical based on reciprocating roller follower but having some offset, and when acceleration is half of retardation, because in first case we have seen acceleration is equal to retardation, or when they mention acceleration is 1/3 of retardation or 2/4 of retardation, in that case what is the procedure we are going to see in this numerical. So let's just start from the statement. So here we have the statement: following data relate to cam profile in which the follower moves with SHM. So follower is moves with SHM during the lift of the follower. So when the lift there is SHM, and return with uniform acceleration and deceleration acceleration is being half of the deceleration. Then minimum radius of cam is given it is 30, RB is equal to 30 mm, that is the base circle radius of the cam. Then roller radius is given, that is equal to 10 mm, so R is equal to 10 mm. Then the next is lift of the follower is 45, so that is S 45 mm. The next is offset of follower axis is equal to 12 mm, that is E is equal to 12 mm. Now next is angle of ascent is given theta O 70 degree, and what this is, during the ascent there is a SHM, so simple harmonic motion is there when follower lift. Then angle of descent is given, that is theta R is equal to 120 degree, and during this there is uniform acceleration and retardation, and acceleration is 1/2 of retardation. That let's put the AR symbol. Acceleration is 1/2 of retardation. Then the next is angle of dual between ascent and descent. So angle of dual between ascent and descent is theta d1, that is 45 degree. Then speed of cam is given, n is equal to 200 rpm. Okay, and they ask for draw a cam profile. So let's start from the displacement diagram. So here we have xy axis. Now on x axis we are going to take a cam angle. So for one rotation it is 360 degree, and on y axis we are going to take a, so let's take the scale. On y axis it is 1:1 because stroke length is given 45 mm, so it is 4.5 centimeter. So let's just mark that much distance on y axis, and on x axis 360 degree angle is 18 centimeter. That is why, because we are taking 1 centimeter is equal to 20 degree. Now on this x axis mark the first outstroke, then dual, then return, and last dual. So outstroke angle is 70 degree, so here we are going to take 3.5 centimeter distance. Then dual is 45 degree, so again it is 45 divided by 2, 20. Then next is theta r is 120 degree, so 120 divided by 2, it is equal to 6, and remaining is last 12. So now draw the vertical line from each angle, outstroke, dual, return, and we have this block for displacement diagram. Now during the outstroke there is simple harmonic motion, so draw a semicircle, that is simple harmonic semicircle, by taking diameter is equal to stroke length. So here we have the simple harmonic semicircle. Now divide this semicircle into 6 equal even number of parts. So let's just divide this semicircle into 6 equal even number of parts. For that let's use the protractor. So I'm just divide this into 6 equal number of parts. Just taking 30 degree angle. So let's give the marking. It starts from the 0, then 1, 2, 3, 4, 5, and this is the part 6. Now as we divide this harmonic semicircle into 6 parts, let's just divide this outstroke with 6 number of parts. Now as we know, this outstroke is 3.5. Again, let's just draw a slope line. Let's say I am here going to draw equal to 3 centimeter, because 0.5 marking is easy for 6 parts. So just draw a line with 3 centimeter at any angle, then join this last point with this end point of outstroke, then just draw a parallel line from the marking dividing point, which cuts your outstroke length into equal even number of parts. So here we have the point 0, then 1, 2, 3, 4, 5, and here we get the 6 part. Now next is just draw a vertical line from this dividation point on the outstroke length. So here we draw the vertical lines, and we know that need to draw a horizontal line from the dividation points on simple harmonic semicircle. So here we are going to draw horizontal lines up to the outstroke length, then just mark intersecting point. So first we have the intersecting point here at 0, then for the vertical one line and horizontal one line we have the intersecting point. Similarly, vertical 2 and horizontal point 2, vertical 3 and horizontal point 3, vertical line 4, horizontal line 4, 5 and 6. Now just draw the smooth curve from this intersecting point. This is your simple harmonic motion during the lift of follower. Now there is a dual period, so that motion is continue up to this distance. It is a constant for the dual period. Now next is return stroke, and during return stroke there is a uniform acceleration and retardation, and acceleration is not equal to retardation. So this displacement, that is for stroke length and that is for theta r angle, is not just half for acceleration and retardation as we have seen in first numerical. Now let's just calculate then, because here they said acceleration is half of retardation. Okay, when acceleration is half of retardation, it means we have, so as we can see, acceleration is half of retardation. So here we have a upon ar is equal to 1/2. So, or in other word, we can say that theta r1, that is rotation angle of cam during the acceleration, is to the rotation angle of cam during the retardation is 2/1. Okay, so this is the criteria. As acceleration is half of retardation, then theta r1, which is the angle of acceleration, and theta r2 is the angle of deceleration, is 2/1 with the ratio. Similarly, for s1, that is the stroke length during the acceleration, and stroke length during the retardation is also equal to 2/1. So as acceleration is 1/2 of the retardation, this stroke length is s1 upon s2 is the 2:1, and also the return stroke angle theta r1 divided by theta r2 is equal to 2:1. We have the proof derivation for this theta r and s stroke length when the acceleration having some ratio for cam rotation, and for stroke length it is opposite of that ratio. So we have the derivation in SS Ratan book. If you want more detail, then you can go through it. So let's just calculate first theta r1 and then theta r2. So we have this equation, so from that we can write theta r1 is equal to 2 theta r2. This is equation 1, and we know that theta r1 plus theta r2 is equal to 120 degree. So let's just put the value of theta r1 from the equation 1 in this equation. So it is 2 theta r2 plus theta r2 is equal to 120 degree. It is 3 theta r2 is equal to 120. So theta r2 is equal to 40 degree. So theta r1 is equal to 80 degree. So in this way we get angle of rotation during the acceleration and during the deceleration. Now similarly, let's calculate a stroke length during acceleration, during deceleration. So it is 2:1 again. So S1 is equal to 2S2. Similarly, we know that S1 plus S2 is equal to 45 in mm. So let's put the value of S2 in this equation, or value of S1 in terms of S2. So it is 2S2 plus S2 is equal to 45. So 3S2 is equal to 45. So S2 is equal to 15. So S1 is equal to 13. So in this way we get the stroke length during the acceleration and during the deceleration. So this is the necessary calculation when they mention acceleration is some ratio to the deceleration. As they say acceleration is equal to deceleration, then no need to do the calculation. We are only taking that this angle is half and stroke length width is half for acceleration and deceleration. I hope you get clear. Now let's just continue with our displacement diagram for return stroke. Now our stroke length during acceleration is 30, so mark that distance 30. Remaining is the stroke length during the deceleration. Similarly, we have the outstroke angle theta r1, return stroke angle theta r1 and theta r2. So theta r1 during the acceleration and theta r2 during the deceleration. So first is the 80. So again mark those angle and draw a line. Now here we are going to divide this outstroke and return stroke angle during the acceleration and during the deceleration with equal even number of parts. Now here we have 6 mm, so we are going to directly divide into 6 equal even number of parts. So here we have the 4 division in acceleration and 2 division in deceleration. Similarly, for stroke length we are going to divide the upper stroke length into 4 equal number of parts and the stroke length during the return is into 2 equal number of parts. So now divide these first 4 points with the first corner of return stroke and join these last 2 points with the last corner of the return stroke, okay, as we have seen earlier, and draw a vertical lines from this dividation point during the acceleration return stroke angle and deceleration return stroke angle, and similarly give the number 6 right here. So 7, 8, 10, 11 and 12. Again start 6 from this point, 7, 8, 9, 10, 11 and this is the 12. Now mark point 6 is right here because this is the 6th vertical line. Now this cross line, cut the cross vertical line, then second cross line with the second vertical line, third with third vertical, that is 7 7, then 8 8, then 0.99, then do it for the 10, then cross vertical with this vertical line, and last point is meet at here. So again join these points with the smooth curve and you get the curve for uniform acceleration and retardation during the return stroke when acceleration is half of retardation. So as you can see, the acceleration is 1/2 of retardation, means acceleration is doubled of the retardation. Now let's draw the cam profile. To draw the cam profile, we have the base circle radius equal to 30 mm. So take 30 mm in your compass and draw the base circle. Okay. Now this is our current axis of cam, but here they mention there is offset, and offset distance equal to 12 mm. So from the center of the cam, take a distance equal to 12 mm and mark a point and draw an axis line from this offset distance. On this line we have the follower. We have the roller follower having radius equal to 10 mm. So take that much distance into your compass and draw a roller from the offset line. So here we have the construction of roller follower. Now as we have seen, this roller is the offset with the cam. Now join the center of roller with the center of cam. So this is important step when offset is mentioned. So join center of roller with the center of cam, and now draw the circle passing from the center of roller and which is concentric with the center of cam. So what is that circle? It is our prime circle. Okay, so here we have this prime circle. Now let's divide this cam into outstroke, return stroke and dual angle. Now we are taking outstroke angle from this center points where we join this center point and we get this line O1. From this line we are going to take first outstroke angle. Okay, so that is 70, then join with center via line, then the dual is equal to dual is 45 degree, so take next angle equal to 45 degree, then return stroke is equal to 120 degree, so here we get the division of angles. So here we have theta O from this line to this, then theta D1, theta R and theta D2. Now divide this outstroke angle on prime circle with the same equal even number of parts that we already divide in displacement diagram. Okay, so let's just divide this outstroke into 6 equal number of parts. So here we have 6 division for outstroke. Here is the point 0, then with this first line mark number 1 on prime circle, number 2, number 3, 4, 5 and 6. So here we have 6 division for outstroke angle. Now follow the similar procedure that we already seen in numerical number 1. So take the distance equal to 1 to A. So here we need to mark ABCD number for these intersection points. And M. Okay, so take 1 to A distance in your compass, and from point 1 on line 1 mark a point A. Okay, so here we get point A. Similarly, take 1 to B distance in your compass, from point 2 on line 2 mark point B. Similarly, 3 to C, mark point C, then 4 to D, mark your point D, then 5 to E, mark point E, and last is 6 to F, and mark point F on line 6. Here we get A to F point. Now then there is dual period, so for dual period the point F and G are the steady position. So here we directly drawn FG curve. Now join this ABCD point with the center of circle with a smooth curve, that is your peach curve. Now similarly divide this return stroke into equal even number of parts that we have done in displacement diagram. Now in this displacement diagram there is a one concept related with this. Acceleration is 1/2 of retardation, so we get theta r1 and theta r2, angle of return during the acceleration, angle of return during the deceleration. So let's just mark those angles firstly in this return stroke. So theta r1 is 80 degree, so I'll just mark here 80 degree, and remaining is the theta r2. So theta r1 and this is the theta r2. Okay, now here we have division of theta r1 is 4 and division of theta r2 is 2. So let's just divide this return stroke into equal even number of parts, that is 4 and 2. So as this return stroke is 120 degree, so it is easy to divide into 4 and 2 even number of parts. So here we have the division 6, 7, 8, 9, 10, 11 and 12. Now take distance equal to 6 to G that we already taken, 7 to H, and on line 7 mark point H. Similarly 8 to I, so from prime circle take a distance equal to 8 to I, then 9 to J, then 10 to K, 11 to L, okay, and last is the 12. 12 is at the same line. Now join this point with a smooth curve, you get this peach curve during the return stroke. Again this is the dual period, that is last 12. Okay, so here we have the peach curve. Now as we know, first we get peach curve in case of roller follower. Now we are going to draw a cam profile, but before that, from this ABCD point we need to draw a circle equal to roller diameter, considering ABCD as a center of roller. So from this ABCD point I am going to draw roller, because we know in case of roller follower, as cam rotated in this direction, roller follower will be rotated in this direction. Now to draw the cam profile, as we can see, this roller is tangent to this base circle. Now from that point just draw a curve which is tangent to the roller smoothly, and that is our cam profile. So again it is meet at base circle, So this is our cam profile. So this red is cam profile and the green line is the pitch curve in case of roller follower, or here is the offset roller follower. Here we finish with the question. Now they ask calculate the maximum velocity and acceleration during the lift. So that can be calculated using a formula that we have already seen while studying the analytical method of displacement diagram of follower. So I hope you get the concept how to draw the displacement diagram and how to draw the cam profile. Thank you for watching video.